And welcome to Inventor Smart Design and Workflow webinar. Well, I would like to first start with a sound check. Could you hear my voice exactly? If you have a problem, please use chat site and type your problem, and then we can recognize the issue. If you hear well, that's okay to go. Great. So as I see, there's no problem in the sound quality. So thank you again to attending Inventor Smart Design and Workflow webinar. My name is Timuçin Taşdemir, and I will explain today Inventor capabilities and how can we use it in design and what is additional benefits of Inventor. We will look over that. So we have an agenda, and that agenda starts with design as a workflow. And this chapter, I'm explaining you what is the workflow or design process in Inventor. Then we will look at iLogic functionalities and customize technical drawing, frame model, different extensions, and lastly, I will accept your questions and try to answer it. And if you have any questions during the webinar, please share with us, and you can type your questions to chat site, and then we can answer it. And let's get started. So first topic, design as a workflow. In Inventor, we have a process to design something, design an object, design a model. So we need to start with a sketch, a 3D sketch. That can be a 3D sketch or 2D sketch. It doesn't matter, but we need to use sketch. So then, based on that sketch, we need to use base feature to create an object, to use extrude or revolve or loft command, to shape an object, draft layer. Then we need to add additional sketch and another feature. Lastly, we can get our model. If you have more complicated model, you can use a lot of sketch and you can use a lot of features, but it based on your model complexity. If we would like to create a sketch, we will use Inventor sketch ribbon. Inventor has some geometric creation options in sketch ribbon, and you can reach that options via part template. So you can create arc, line, circles, or rectangles, polygons, and others. Also, you can modify these geometric creations, and you can trim, extend, offset, scale, copy or rotate, or pattern. Also, you can give a dimension, and you can apply constraints to these sketches. Well, I would like to show you Inventor sketch environment in an empty part model. So first things first, if you like to open an empty part model in your Inventor, so you need to go home panel, that side. That panel is a home panel, and you need to click open new. So Inventor will ask you which template you would like to use as a base template. So I'm using metric template and standard part 1, and click OK to open. You can use Inventor standard templates, or you can create your own templates for your company or for your institutions. So when you log into part panel, as you see, there is some features about part and modifying it, creating new parts and or some geometrical operations. But as I said, if we would like to create a model, a 3D model in Inventor environment, we need to use Sketch. So I'm clicking to this Sketch, and after that, Inventor asking me to select an plane. Basically, there is 3 initial plane available in Inventor, and you need to select one of them. So I'm selecting XY plane, and then the Sketch environment activated. And as you see, there is some Sketch features available. Here's the line, and you can use it to create line, or you can use from shortcut menu, and you can create your own geometry. And also there's a circle, and you can create your circle again. So there is an arc, and you can use that arc features if you have some dimensions or some constraints available here. So we can create our part model sketch or base sketch by these features. That is Inventor environment. So I'd like to continue on my PowerPoint to explain the other things. So if we create a sketch and we model our part, and then we can create our assembly based on these parts as a component. So we need to give some constraints and assembly mates. So before to go, I'd like to show you some part creation stuff and how can we manage these files in Inventor, and how can we create that. So I would like to delete all of that, and I would like to share you a simple part creation and an assembly made and using constraints in Inventor. There is some questions that coming during that session, and I will answer all questions. But just for now, I would like to continue to create a simple part and show you the design process, and then we can look over your questions together. So simply, I'm creating a center point circle and giving a dimension, as you see. And then I will finish this. And create my base feature. And I will use that sketch for extrude, approximately 25. But we have some additional information and options here if I would like to use some angle to give that extrusion, such as, for example. But my design is 0, so I'm just leave it like that and click OK. Now my base feature is ready. I'm clicking top surface of it and creating a new sketch, and I'm drawing a rectangle, a center point rectangle to top surface of it. Then I will give a dimension again as 25 and give a dimension again and click OK. Now my second sketch is ready to use for extrude, and I'm selecting that sketch and typing 10 for extrusion, and I'm also typing 20° for angular value, and click OK. Now my cut feature is ready. Then I would like to pattern that feature and selecting cutting feature and selecting rotation axis and typing 2 and giving the rotational angle and click OK. As you see, my 2 cuts now available on the model. So that is one of my first model, and I would like to create a second one together. Again, I'm using a rectangle and giving 25 dimension, and also giving 10 millimeters. So 25 as angular. Now it's ready. Then I'm clicking another sketch and drawing a circle that tangent with that side and giving additionally 2 millimeters extrusion on it. So, but my work's not finished. I would like to open a hole here, and I can use sketch, but I can use hole feature, and I'm selecting concentric and selecting top surface of the hole and selecting concentric references of the hole and typing 20 or yeah. And my hole is blind, so I can use that arrow to arrange, or I can use that side to select one from standards. So I'm selecting unsymmetric and size and designation and class. And yes, that is okay. So my hole is added. So if we continue to do something like that in part environment, we can design all parts, and we can use some similar commands together. I just would like to give you a basic idea of Inventor usage and how can we use it, how can we locate it. But I didn't mention some fast track options such as shortcuts, such as customizing user interface or customizing ribbon or customizing shortcut menu. That is beyond of this webinar, but I just would like to share you the basic idea of part design. So just think about that. We design all parts and we would like to an assembly, and we need to use mates. So let's look at together. I'm opening an assembly template. Assembly templates is different than part templates because you can use part templates to create model, create feature, but you must use assembly templates for components, for mate to components or combining components. So that is the difference. So that similarly, we have these origin axis and planes, and you can use it as start. I just like to hide again, and you need to add a component from your PC or some sources to start the assembly. So I would like to add our first design component here. So I'm clicking place components. Then I'm going to my part here. I'm just clicking here, and as you see now my mouse just showing that, right clicking, place grounded at origin. That command helped me automatically placing that component to origin and grounded. So how can it place origin? So there is a simple explanation over here. That is part origin. That is assembly origin. Simply Inventor just coincidence both of them. So I add my part and it's grounded. The mean of grounded, it cannot move. If you right click and just unclick the grounded, your part can move it, but it's okay. I don't want to see a moving part in my assembly. So I am adding the other part here that I will use. Here's my part, and we can start to give some mates between components. So I'm simply right click and open place constraints. In Inventor, if you give mates between parts, between subassemblies, between part and subassembly, it doesn't matter. You know that if you give mate between components in your assembly, the components mean part, assembly, whatever it is, the component of assembly. So if you would like to give mate, you need to use constraint command. Constraint command, there are several constraint options for components. As you see, coincidence or concentric or angular alignment, and etc. And also there is some motional constraints and transitional constraints. But we will use in that example assembly constraints. So I am selecting that surface and that surface and clicking apply. And I would like to also give a constraint between that face and that face. Yes. But as you see, there is a problem here. The components and the cutting feature not equal as length. So I would like to look at what is the differences. That is showing my diagonal. I would like to look at X, Y, Z differences. As you see, the differences is 4.25. So I need to fix that issue. So how can I fix it? How can I fix it? So you can fix in your assembly environment. I'm double clicking on the base model, and what is my extrusion? The second one. I'm right clicking on it and clicking edit sketch. So I'm just double click the weight of the sketch and typing -4.25. Then click OK. New dimensions just updated, and I'm clicking finish sketch. As you see, my old model just updated, and I'm returning top level assembly. Now there's no problem. As you see, it's now equal. So when I add that, I need one more for that side. I'm just clicking on my 2B model, and on my keyboard, I'm clicking Ctrl+C and Ctrl+V. My new duplicated component just added quickly in my assembly. I'm using same mates to give relationship between parts, and now it's did it. Okay, I have a few more components to do. I'm just clicking here, and that made important to use concentric alignments. So I'm selecting that reference and selecting that reference. As you see, that may just give two relationship in one place. I'm adding another relationship, and my road just added. Okay, so my work doesn't finish. I have one more thing. I'm selecting that surface and that one, and just like to add you. Yes, first I need to, and I'd like to use concentric again, and so you can use planar concentric, and now my model is ready. So we can add one more component, or we can duplicate it in that assembly, but just for now, leave it like that. I would like to leave it like that, and then I'd like to explain some movement stuff in assembly. So my assembly is ready, and when I just simply drag and use to see my model's movement, as you see, it's just showing me the relationship. So if your assembly, your mates giving correctly, and your model has a flexibility, just degree of freedom, and you will see in your mates, your mechanism will work, and Inventor can show you in just assembly environment, and then in dynamic simulation environment also. So that is the part feature and design feature and assembly feature of Inventor, and we have a few questions here. I just would like to look at that questions. If you have some questions about that site, I can explain, or we can look at the end of the webinar together. Okay, then let's move on. So, using iLogic functionalities. In that step, I just would like to ask a questions to attendees. Have you ever heard anything about Inventor iLogic? Have you ever heard anything or any idea? Please use chat button or ask as a question. I'm really wondering your answers. If you have some ideas, then we can discuss on it. So let's look at that. I have a couple of answers here. I think you have some ideas about iLogic, and I have questions. I'm just looking at the questions. Just a minute. Oh, I see. So it's about configurations and Inventor capabilities and user user interface. It's about. So that questions especially about iLogic and iLogic environment. I would like to answer that questions during the explanation, if you let. So yes, Inventor has significantly important configuration capabilities and called iLogic, and you can parameterize your model and you can create your own iLogic algorithm for your model. But as you expected, you need to follow some rules in order to do that, because if you would like to give some equations to your model and you would like to give some flexibility, and you exactly use some constraints and you need to set up your rules, and I will explain a little bit in that chapter. So what is iLogic? iLogic is a rule-based design. Simple explanation is that rule-based design. So you have a model and you would like to change your model based on your actions, your selections, or your conditions. That exactly possible with iLogic. So normally in conventional CAD systems, you can create a model, an assembly, and if you need a similar of your model for another project, you need to save as your assembly, exact assembly, then open it and modify it, and you can create your copied one, or you can create your edited one. That is the oldest way that designers are using exactly today. But iLogic is different that way. You don't need to open and redesign your models. Just you need to set up your conditions, your workflows, your flexibility about model. What is the mean of flexibility? The mean of flexibility is that which parameters must change my model, which parameters not. The definition of that. So you need to decide that first. So what will change my model? Customer, industry, or base, or length, or product? What is that? So you need to first answer these questions to understand the flexibility of your model. Then you can type algorithm. I'm developing algorithm for 4 years and using programming language, and I can say that the hard side of developing an algorithm or typing codes is definition. So not typing if, else, or some programming stuff. That is easy side. The hard side is thinking. So thinking and deciding what is the flexibility of the model. Secondly, I'd like to share that if someone not familiar with programming and maybe afraid of programming, iLogic is not exactly a programming tool. In fact, you don't need any programming language to use iLogic. So you don't need to know a programming language. You can directly use iLogic if you know design principles. So easy to use and easy to learn. So, and there is a user-friendly window here to type and edit your code, and I will explain a little bit. In simple creation workflow, I explain we must first create a sketch, then we need to create a base feature, then we need to create another sketch, additional sketch, and integrate another feature, and finally our model will ready. But in iLogic perspective, you need to do that workflow or follow that workflow. So first, you need to define model flexibility. Then you need to create a sketch, and you need to create your features and define parameters and sketch feature model. Lastly, you need to run your mod rule. So that is the simplest way to use iLogic functionalities for your model. So I explain iLogic and what is the base of iLogic and what we need. And here is some iLogic screenshots from my computer. These codes that I developed for simple stuff, and you can create your own codes in Inventor environment. But more important from that, maybe you think, what is the exactly benefit of iLogic? What is the advantage of iLogic? What is that? So why I need to use iLogic? Why I need? What iLogic give me additionally for my job or for my ability? So that's a good question. And simply, I would like to explain on my Inventor screen. So let's switching Inventor and closing these models. Here's my models. In Inventor environment, as you see, that is a Kids Park. So a simple Kids Park and infrastructure stuff for our business. But also the mechanical customers, manufacturing customers producing some kind of stuff. So you have an assembly model like that. And as you see, this is a simple Kids Park and some rollers and some heads, chains, etc. So if I ask a question to you, if you would like to change that model a little bit more, for example, 2 rollers and less sliders and etc., or some different sliders, how much time it takes to edit that kind of assembly and create a new one? So do you have an idea? Just think about your need to redesign that model based on that design, but you need to change some stuff of that design. If you have an idea, please share with us. And I'm really wondering what is your opinion about that. And by the way, I can share my opinion, and it can take more than 30 minutes to do for in old way. So how much it will take if I use iLogic functionalities? That form, physical playground, we created, and I can change my model based on that form, and exactly you will see how automatically Inventor will change the model. So simply, I don't want 1 base, I want 2 base. Then select 2. As you see, my model just updated. So I don't want a bridge, that side, the middle side. I want a tunnel. So I don't want swing set 3, I need just 2. As you see, swing set just updated. So I don't want to see rock wall, I want climbing boards. I'm just change it, and as you see now it's climbing bars. So the slide color and the other ones. As you see now my model just updated in seconds. So that is the power of iLogic. iLogic can help you to reduce your design time and exactly creating rule-based assembly and perfectly matching your project. That is the benefit of iLogic. So because of that, you should use iLogic. Also, you can publish your drawing, your model, and also your part list via iLogic automatically. That's possible. So how is working? How is it working? Let's look at that on a simple model. I would like to open a simple model about that. Yes, that one. I think okay. So that is a simple model, and I would like to share you with via on a material rule how iLogic can work, or how can we use it. So first thing first, we need to create a rule. So Inventor will open my rule editor window. At that site, I would like to share that information with you. Normally, you can create some similar things via Inventor API, application programming interface. So you need to use some programming language, but in iLogic, you don't need anything else. Just iLogic functions enough to create rules. So I need to use that panel to create my rules and these logical blocks and keywords and operators if I need, and parameters if I need. So I'd like to add a parameter, a user parameters, and create a text called material, and doing that multi-value and typing brass, gold, and steel alloy, and click add. So my user parameters is ready. I click done and click my material rule. Then I'm selecting if expression and typing my material rule, brass. Then I am selecting material code, brass. So the meaning of that, if my material, user material is brass, please apply it features as material brass. So I'm giving that order to Inventor. So I'm adding that code here, and again adding my material gold. Then again I'm adding I properties as gold. One more, I'm just copying that and pasting here steel alloy. and typing here steel alloy. So that's it. That is my material rule. And typing and 7 run. There is maybe I did a mistake, maybe steel alloy, just it should, yes, brass and maybe here. Let's look at that and yeah. And I brass here, yes, steel alloy. Everything is okay, as you said, steel alloy. Yes, steel alloy and gold. It seems to me okay. So I'm just looking again. Brass, gold, steel alloy. Okay, it seems good. Yes, my rule just worked. So I'm changing, as you see, my user parameters. Here's a problem, but it's okay. It's just working. So that's a simple explanation of iLogic. But because you can create your rules based on material or based on dimension of your sketch. But you need to type your code correctly. That's important. Okay, so I explained the iLogic stuff. Then we can move on about customize technical drawings. So we can use iLogic and we can also use that functionalities to fill or technical drawing titles. So Inventor simply has almost all standards. But what about if we would like to see a custom one or for our company? How can we do that? So that is important. Because we need to create a custom template to use every time to create our drawings for our business. That is important and so easy to manage in Inventor. So in order to show you how can we do that in Inventor environment, and I'd like to select my active project and open a template such as yes, ANSI one. Here's my template. So simply if you add a model here, as you see a model here, simply we can add that one. Some model properties should come here. So in order to do that, we need to change title blocks and weave or drawing resources. That is title block, that is border, and we need to change title block. I'm just clicking, just deleting that, and I need to change that. For example, let's edit. That is my title block. So you can customize these values based on your project or your model. I just would like to simply add material properties here and show you how it's updating. I just duplicated these values and just select properties of model and material, click OK, change it as material, and finish sketch. Save as it's my company template or title block in order to use every time. So I insert it. As you see, my material just come. Also, I would like to insert a border. So if I change that material, let's look at that. If I change that material, I'm opening the model and select, for example, steel alloy for just example. So I'm returning and looking at the title block. As you see, my title block just updated. So you can use for every item and every custom object or property in your company or for your project. So you can create not only a custom one, also you can create some special properties via Inventor, and automatically you can fill out Inventor title. In order to do that, you need to change or edit your title block as I did here. Normally, in Inventor, all title block information just coming from properties, properties, and the part number, stock number, description, all of that come from properties. Also, these properties usable for Autodesk Vault, the data management system. But if you have some specific properties not available on that site, as you see, you don't have a description or you have something different, you can use custom properties and create your custom properties for your company, and we can add automatically these values into Inventor drawing. Okay, let's go on. Frame models. Inventor has some frame capabilities to create constructions simply, and you can use for your construction, and you can add that construction in assembly as a sub-assembly, or you can create technical drawing code that you can give a flexibility by iLogic. That's so easy. In order to create a construction in Inventor or create a frame model, you need to start with a sketch. That can be a 3D sketch or 2D sketch. It's based on your choice. Then you can insert the frame, and you can use standards from Inventor Content Center libraries. Here's the library and frame selection. I just would like to show you how can we use it. A quick explanation. I'm just creating a sketch. Select 3D sketch and select line, as you see, and create a line here. I just give a dimension 1 meter, and give another dimension 10 meter and give another dimension, but I'd like to use that one and select D0 and just equally select. Okay, so 10 meter and 1 meter. We can just use the shortest one. Just select 5. That's better to use. Okay, that is my sketch, 3D sketch. So I'm just saving that as part 4, and opening an assembly. Then placing that sketch into assembly, as you see, and here's my model. Okay, so now we are in assembly environment and we would like to add frame. First we need to save it, and then we can select a standard frame. So first thing first, you need to select a standard. Which standard you use? ISO, ANSI, or DIN. You can select, and then you can select a family from that standard. For example, I selected rectangle, hot rolled, and selecting that frame family size, and as a material, steel alloy again. Then I'm selecting just by the lines. So before to go, I can share that. Here's some offset values. You can change your model alignment, or you can just offset your model, as you see, like that. So I'm just typing all of that 0 and click apply and click OK. Now my model is just available, but there is a problem here. I need to edit that corners, so I'm just clicking Inventor and select these two, click OK, then again select these two, click OK. So I can use the other ones, but for now I use middle one. My simple frame model is ready, as you see. So in Inventor, you can create your frames like that. It's whatever it is, so complex or so base, it doesn't matter. You can create, and Inventor automatically create a sub-assembly for that model and create every item as a part, as you see, and applied all operations based on your frame assembly. Okay, so after that, I can share the strength of frame side. If you calculate your frame performance or your frame stability or strength, and you can use beam and column calculator in frame panel, and you can apply loads or moments or torques, and you can give constraints. Then Inventor can give you moment diagrams, section force diagrams and torsional bending stress diagrams. That's possible by Inventor. If you have a question for that site, please feel free to ask. Okay, we can continue if we don't have a question. And lastly, I'd like to mention different extensions. Inventor can open different extensions. So shortly, I would like to describe that feature. Inventor can open CATIA, NX, Creo, SolidWorks, and AutoCAD step file format, and as well PTC Creo, and can export these files. That functionality called AnyCAD, and AnyCAD is an enhancement from 2017 series, and you can use some different extensions and assembly components directly in Inventor. But I would like to show you via an example. And if you have a different file format in your model, just like to change my active model default and like to select mine. Here's my model. So that model is a step model, and as you see, it's not native. It's just a base and come from step file. So you have that model and you would like to change some feature of it. You don't need to recognize the feature. You can click direct command and then you can just select the feature and you can change the value of that, or you can change the length of that. That's possible and easy. Maybe you would like to change the location of that holes, and you need to select holes. Then I'm selecting the rotation, location, and changing it. And it's okay. Also you can change the radius of model. So easy to use, and you don't need to recognize feature in order to do something because of AnyCAD and direct functionalities. Okay, we are about to finish. Questions and answers. If you have a question, please feel free to ask, and I'd like to answer your questions. Okay, I think there is not so much questions. I tried to answer during the webinar some of them, and I hope that webinar helps you to understand Inventor family products better. And if you have some additional questions, please reach out to our regional representatives, and we would like to gladly help you about your questions and ideas. So thank you, everyone, and have a nice day, and thank you for your time for that webinar.